This is Leetcode problem 24 called Swap Nodes in Pairs, a medium level problem. You're given the head of a singly linked list and you need to output a singly linked list, the same one, where every pair of values, every two values is being swapped. So you have 1, 2, 3, 4 here, and it turns into 2, 1, 4, 3. I believe that this is one of the only ways to solve this problem simply because I got 100% time complexity and almost all of the solutions seem to be at this same point. So let's go over to VS Code and go over my solution. And because it can get a bit cumbersome with all of the references of node, the next node, the following two nodes ahead, one node backward, we're going to have to go through the debugger for a little bit to try to help visualize what is taking place. First off, what I ended up doing is creating here just a way to filter out any singly linked list that simply have one value or none. And so it'll just return that head right away. I'm making a copy of the red reference to that singly linked list, the head, and then I'm making a counter here. And so while there are still nodes at current and there's a following node, meaning there's a pair of nodes to compare, if it is the first run through this, it's going to run here. The main reason for the count in general is just a way for me to loop and update the original head reference to the start of the singly linked list because we need to swap those two values. After that, I'm incrementing this counter and then I no longer need to update the head. And so then it moves down here. And the way that I'm doing this is it's only incrementing by one at a time for the count, and then we're filtering out anything that is at an even number. And that works out because for this chunk of code here, I am looking 2 steps ahead. So the current node, I am not actually swapping the current node, I am swapping the 2 forward-looking nodes. For instance, here, if we envision that this singly linked list that I just hand-made here is that 1, 2, 3, 4. Let's say I already swapped the 2 and the 1, so now I'm at this node here. What I'm actually doing is I am comparing and altering the following 2 nodes. So only when it's at an odd placement, when the count starts at 0, right? And then it goes to 1, then it goes to 2, then it goes to 3. Only at the odd numbers am I going to actually be running this code. And what becomes cumbersome to describe is simply how you have to update all of these references and how you have to update them in the correct order so as not to overwrite any of the information you're trying to actually save. So note here how I have the furthest value that I'm going to maintain a direct reference to that node is 2 nodes in advance from the current position, and then I'm also going to store a reference 1 node in advance of the current position. And this 1 node that's right next to, I'm going to alter it to be the node after this F node, meaning it would end up being 3 nodes in advance of the current position. And then I'm updating that value to B because the F is going to be switched with the B, so the next reference on the F needs to be that actual B node. And then I'm going to change the current next value to that F. And so that is the main reason why you have to do it in this manner, or that's the reason I chose to do it in this manner, is because if you want to maintain the order of the list, you can't count or increment by 2 at a time because you would lose the current reference. So when you are comparing, you need to still update that current node's next reference to the one that you're changing it to. And in this case, you have F is switching forward and being right next to the current node. B is going after F, and I'm updating all of the references accordingly. And the one thing of note here is just make and pay attention to the order in which I am referencing things. I'm going from furthest away, meaning B next. That's the first assignment to a reference, a direct reference I'm making. I'm altering the switched node's reference first and making it that original F's location's next reference. And then I'm updating F's next reference to become that B, and then I'm updating the current next position to be that F that I stored, incrementing count. That could probably come at the end, and then I'm updating the current node to the next node so it increments forward. Hopefully you're following me thus far. Let's run through the debugger real quick and see if that helps shed some more light on what is taking place here. So originally you're on current value equals 1. Just keep note over here in the left corner here with the watch window. This current value is just the current position we're on, and so that'll give you a better idea of where we are and what node we're at as far as what B is currently and what F is currently. So remember, the one list we're going through is simply a node that has 1, 2, 3, 4 in order, and it's being turned into 2, 1, 4, 3. So right now we have current value. The current node we're on is 1. We've updated the current next value to the third node, which is the B value, the one that's B4. And then the F value we're on right now is that 2. And here, what I have created is unnecessary just because unnecessary to the original problem. It's just going to be printing things out, so we get a kind of a visual. So right now, after that one iteration, you see here on the right, the output is 2, 1, 3, 4. And just make note of where we are. The current node value is still that 1, which in this case, it means we're actually in index position 1 as well over here. That's just what node we're on. And so what we're comparing now is 3 and 4. And so then updating all of those references, and then we'll populate this and see that everything has already been updated. 2, 1, 4, 3. And now, since it was not odd, right? And we're currently, this was still satisfied, we're just going to be incrementing and counting. And then it'll return after it increments far enough. And there you have it. So this is Grover, Blue Collar Codes, Quick and Dirty, Leetcode problem 24. Thank you for joining.